let's go through a few examples of writing equations of lines. Here's a typical example of a question that asks us to do that. Write an equation for a line through the point 2, 1 with slope 4. So that means we want the line to go through this point that has this x coordinate and this y coordinate, and it should have a slope of 4. So there are two ways to do this typically. One is to use what's called the slope-intercept formula. That's the one that's typically taught first. Y equals mx plus b. This is called the slope-intercept formula because the two constants in this equation, m and b, represent the slope of the line and the y-intercept of the line. So the first thing you want to do using this approach is to find the slope. Let's do that over on the side here. So the slope is, well, 4. I'm just making a note of that. Sometimes we have to do some work to get it, but in this case we're told the slope is 4. So we can just plug that in and write y equals 4x plus b. Now how do we find the y-intercept, the b? Well, in order to get that, we have to, in this case, plug in the given point. So I know that if I plug in a 2 for x and a 1 for y, that's a solution of this equation. And the only way that could be the case is if b is -7. Right? Because 4 times 2 is 8, and when I subtract that from both sides, 1 minus 8 is -7. So what that means is my equation for my line is y equals 4x minus 7. So I've taken the slope m and the y-intercept I found b. I insert those into the slope-intercept formula, y equals mx plus b, and that gives me the equation for my line. Now there's another approach. Instead of the slope-intercept formula, you can use what's called the point-slope formula. That formula is written this way: y minus y1 equals m times x minus x1. And the nice thing about this formula is you don't have to think of it in 2 steps anymore, where you plug in the m and then solve for b separately. Instead, you get to just plug in everything right away. So in order to use this formula, you need to have a point, which we do, and you need to have a slope, which we do. The point you are given is what you plug in for this x1 and y1. You don't plug anything in for x and y, because in the end of this, we want to have an equation that will have both x and y in it. That'll be our equation for our line. And in the other approach, we temporarily plugged things in for x and y so that we could solve for b, but we won't need to do that this time. We'll have an x and a y throughout. We will plug in the given point for x1 and y1. So the x1 is the given point's x value, 2, and y1 is the given point's y value, 1. So when we plug those in, we have y minus 1 equals m, which is 4, times x minus 2. So then the next thing you'd usually want to do is isolate y. And in this case, I can do that in 2 steps. I distribute this multiplication by 4, so I get 4x minus 8. And then I add 1 to both sides. -8 plus 1 will be -7. So it's the same answer we got before, just a different approach to get there. Now, the slope-intercept formula, the one we did first, is the one that people usually learn first in algebra. But this point-slope formula is really useful. It can make things a lot simpler sometimes. And so that's the one that we will use for the remainder of the examples in this video. It might be a good exercise to go back after the video and try to do the other examples using the slope-intercept formula to make sure that you can get the same answers. So let's see what happens on this one. Write an equation for a line through these 2 points. All right, so last time I was given a slope. This time I have to figure out the slope. That's the first thing we'll do. So remember, slope is the change in y divided by the change in x. So you can think of that as the difference, y2 minus y1. That's how much y changes between these 2 points, divided by x2 minus x1. That's how much the x value changes between these 2 points. So I'm going to use the first point here is what I'm referring to when I talk about x1 and y1. The second point that we're given is what I'm talking about when I refer to x2 and y2. So those are the values I plug in here, right? The change in y is the difference between these two y values, 7 minus 3. The delta x, the difference between the x values, is 4 minus 2. So when you simplify that, in the numerator you get 7 minus 3 is 4. In the denominator you get 4 minus 2, which is 2. And 4 over 2 can be simplified to just 2. So that's our slope. That's what we'll use. And then I said I'm going to use the point slope formula. Y minus y1 equals m times x minus x1. And it's a good idea to write this formula down every time you use it. It'll help you remember it. Now I just need to plug things in. My y1 is 3, m is 2, and x1 is 2. And if I isolate y here, I start by distributing this multiplication by 2, so I get 2x minus 4. And then I add 3 to both sides. Negative 4 plus 3 will be negative 1. And there's an equation for the line through those 2 points. By the way, if I had decided to switch these to call the second point x1, y1, and to call the first point x2, y2, and I plugged those values in everywhere, the work might have looked different along the way, but as long as I don't make any mistakes, by the end I will have the same final answer. Let's do another. This time we want an equation for a line through a given point, 1, 5, that's parallel to this other line. So what does it mean to be parallel? Well, when you're talking about lines, you know, lines are parallel when they have the same slope. Or when they're both vertical. Vertical lines have an undefined slope. So if two lines are vertical, if they're both vertical, obviously they're parallel. If they're not both vertical, if they're at any other angle, then they're going to be parallel if they have the same slope. Well, take a look at the line we were given, y equals 3x minus 1. We can see right away that that line has a slope of 3. So because I want a line that's parallel to that, my line should also have a slope of 3. Now I'm ready to use my point slope formula. Y minus y1 equals m times x minus x1. Plug values in. My y1 is the y value of the given point, so that's 5. M is the slope, 3. And x1 is the x value of the given point, which is 1. Simplify this. y minus 5 equals 3x minus 3, and then add 5 to both sides, y equals 3x plus 2. Let's do one more example. This time, I want a line through the origin, so note that that's the point 0, comma 0 when we talk about the origin. We mean the point where the two coordinate axes cross at 0, 0. And we want our line to be perpendicular to this line. So what does perpendicular mean? Well, it means that the lines cross at a right angle. And so obviously they don't have the same slope when they're perpendicular. In fact, the relationship is that their slopes are negative reciprocals of each other. So if I want something that's perpendicular to this line, my slope should be the negative of the reciprocal of this slope, 2. So first of all, the reciprocal is 1/2. And the negative of that would be negative 1/2. That's my slope. And again, plug it into our slope-intercept formula. My y1 is 0. Slope is negative 1/2. This is supposed to be an x1, not an x2. X1 is 0. And when I simplify, I just get y equals negative 1/2 x. And that's an equation for a line through the origin. The slope is negative 1/2, which is the negative of the reciprocal of 2, which means these two lines will be perpendicular.